Without further ado, let me introduce the speaker for today, Ashutosh. Hello, Ashutosh.
Hi
So, Ashutosh
Prasad.
is the networking specialist at AWS. I'll let him introduce himself to you all.
Hello everyone. Good morning, good afternoon. Thanks for joining. Coincidentally, it is April Fool's Day, but we are serious here, and we'll go through some of the stuff which is actually close to my heart because I did networking throughout my career. So just a little bit of intro from my side. I'm Ashutosh Pateria. I'm one of the solution architects with AWS. So I support my customers in Europe region, mainly with networking related issues and architecture in general. Um, so today we have a couple of topics which we'll go through, and we'll try to just see some patterns, some anti patterns, and something which is kind of written in documents but it's not very clear, so some actual practical tips which you can use in your real life while architecting, and you can just refer these to make your design a little bit better, right? So, since this is a networking session, I'm assuming that everyone has a basic understanding of networking. What is an IP address? What is a CIDR block? What is a subnet? What is a VPC?
Yeah,
Um,
Ashutosh, actually, in the previous sessions, Ashish did take some of these primer. So we are hoping that audience would be knowing those things. So
okay,
yeah, these are 8 series session. So in the
yeah,
first seven, Ashish, the first couple of sessions, Ashish did cover few of the basics of networking from the very scratch. So we are hoping that people would be aware of IP addressing, subnetting, or the OSI model, all those kinds of stuff. But yeah, before we start, how I know Ashutosh is that me and Ashutosh joined AWS on the same day. That's how I got to uh, know Ashutosh, and like I come from a development background, and I do not have much of networking exposure. So Ashutosh has been my go-to person for all the networking queries in the last 3 years. Um, so yeah, it's an honor to have him here. Because he works day in and day out with customers, actually solving one of the most complex problems that the customers have in their like AWS network and even hybrid network. So yeah, I think Ashutosh, I'll share I'll put your stream onto the
yes, please.
stream, and I'll remove myself, and I'll hand it over to you to get started.
Thanks, Prasad. Okay, so is everyone able to see my screen? Uh, think yes. Okay, that's great. Okay, so this is week 8 of our technical sessions. So in this we have uh, we have tentatively 2 hours. We'll go through a mix of some theory and some hands-on, and at the end I have something very interesting for you. So I since being in networking, you get little privileges in AWS. So what I noticed in my 3 years working with AWS, that you can simulate most of the things except direct connect. So direct connect is something which is actually physical thing, right? So it's a fiber connection from your data center to AWS, and that is something you just read about. You don't get a hands-on on direct connect. Luckily, I have a rack here in one of our London direct connect peering exchanges, so which I reserved for today's session. So I'll just go through the whole direct connect ordering process, how it feels like, and we'll provision the direct connect, and we'll send the traffic from the data center, like from on-premise to AWS and AWS to on-premise, just to give you a feel of how it actually looks like in direct connect. It is actually very simple, but since we don't get to do the hands-on, it feels little bit complicated. So the idea is to give you um, uh, a feel of the direct connect. So we'll take questions at that time if you have any, and I'll give you some tips and tricks also. Right now, first topic of today is auto scaling. Right, so AWS has a service called auto scaling. So we'll go through it, some use cases, what are the types, and various components of it, and how it actually works, and we'll have a little demo also how to configure, because in AWS, more or less, configuration is the easiest part. You need to understand the logic behind it, and how to use it in your day-to-day design, right? So what it is actually, so in a plain and simple term, it is a service which continuously monitors your applications and automatically adjusts the capacity of your servers based on the predictable performance of your application, right? So you have, suppose, one web application which does, suppose it is an invoicing application, it is running on, so you baseline it to run on 5 servers. Now this auto scaling service will make sure that you have those 5 servers always available to give your customers the best performance, because if the server farm has less than 5 servers, then your application might drop few of the customer requests, right? So that this auto scaling group is an auto scaling, rather, is an automated process of scaling up and down your resources. So it works with, most popular is for EC2 instances, but it works with EC2 instances, ECS tasks. You can scale Aurora replica with it. You can have DynamoDB tables and indexes, and EC2 spot fleets also you can scale up and down. Right. So it it has a couple of components. So just don't worry too much about theory, but I want to give you an overall, these are the building blocks which come together and make the auto scaling feature as such, right? So just don't focus too much on the terminology, but just try to get the idea, right? So it has three main components. One is group. So it is a logical collection of your instances, your compute instances, wherein you mention that you need minimum number of instances, you need these many maximum number of instances, and these are the desired number of instances. So logically it becomes a group of your a pool of your EC2 instances, so which is called group. Like, group is a pool of members, right? So we call it auto scaling group. Then, as you know, with every EC2 instance, when you launch, it needs to have a minimum components. Like, it needs to have some operating system, we call it AMI, Amazon Machine Learning Image, sorry, Amazon Machine Image, and it needs to have some sort of hard disk, we call it EBS. So there should be some boot volume attached to it, and if you want to use SSH, it needs to have key pairs. It needs to launch in a VPC. So you need to have a VPC also. You need to have your um, subnets, which subnet you are going to launch this into. So all this configuration we package in the configuration template. We call it the launch template. So launch template, configuration template, more or less are the same. They are actually the same thing, but the new term is the launch template. So it helps. So you can remember like this: when you launch an EC2 instance, you need a launch template to launch that EC2 instance, so that it picks the data from that template and it launches the new instance based on the data which you have already provided. And the scaling options, right? So auto scaling provides you various ways of scaling your services up and down, right? You can have based on a schedule, that every day at 6 p.m. scale my instances from 10 to 100, or maybe based on some previous historic performances, that a trend that every week, Monday, Tuesday, your service demand is low, but Wednesday, Thursday, Friday, it is high. So based on that predictable demand, you can increase it, right? You can have it dynamically also. It will keep on tracking your compute fleet, and based on the triggers you have mentioned, suppose number of connections or memory on your servers or the CPU, right? Based on that, it can generate a CloudWatch alarm, and that will trigger the scaling policy, right? So it can trigger, suppose you baseline your application which runs best when the CPU performance is at or below 60%. So when it hits 60%, you can start the scaling so that your customers still have better experience, if not best experience, and none of the incoming request gets dropped because you have more servers available because the scale out event has already been triggered, right? And this service is free of cost, so you don't pay anything for it. You only pay for the AWS services which you are consuming. Suppose uh, after scaling event, you are scaling 5 new EC2 instances for 2 more hours, right? Then you just pay for those instances and the EBS volume you use, right? Now let's discuss little bit about, sorry, auto scaling groups. So it looks like it looks something like this, right? So you create a group wherein you mention that uh, I need minimum one instance. Obviously, you need at least one instance, but this is just an example. In real life, you will have hundreds of thousands of instances. But for your application, so suppose this is a group we created, we need minimum one instance. Maximum scale, it can scale out to 4 instances, and desired capacity is 2. Now there is very interesting thing in here, like when you say that we want to give our customers the best experience, why not keep on scaling out if demand increases, right? Because if customer needs, suppose our customers are increasing and we are hitting more traffic and we have limited it to 4, in this case 4 instances, and if these instances are overwhelmed, then customers will have the bad experience because new requests might be dropped, right? So this is actually a fail-safe mechanism. So consider a scenario wherein your application, your public-facing application is DDoSed. So it is there is a DDoS attack, distributed denial of service attack, right? So what it does, it sends from hundreds of thousands of compromised machines, mobiles, whatever those client devices are, legitimate requests. So suppose it is a web application, so legitimate web requests to your website, right? Since it is legitimate, it your system may or may not be able to detect that it is a DDoS, right? There are some machine learning mechanisms, and we have services to detect, even the HTTP request is properly formed, it can detect based on the pattern it's a DDoS, but that is for some other day. But it will send the request, right? Now, if suppose there is no maximum size, right? So you we
Ashutosh,
yeah.
sorry, just one thing. Uh, there's a request to there's a small like window you are sharing your screen on the main screen. If you can remove that, if it's possible to
Oh,
minimize
this
it.
question.
Yeah, yeah, yeah.
Oh, I'm so sorry.
No, no problem. And second is there are a couple of questions on not able to if you can clarify what a minimum size and desired capacity, what's the difference
Okay.
between the two?
Yes, sorry, actually it's in the second screen, so I
No
have.
problem. Yeah, please go ahead.
Yes. So see, minimum is you need to have these many instances to make your auto scaling group work. Otherwise, auto scaling group will terminate. Essence, like if you do not have minimum number of applications, sorry, minimum number of instances, then your application will not work, right? So uh, let's take one example. So you have some application and you baseline that application that it works with, if I have at least two servers or one server, it works. So you need to have those minimum number of servers available for that application to work, right? So this is the minimum we define, right? If we don't define minimum, then these services, uh, if they are getting terminated, auto scaling mechanism will not mitigate it, right? So if you did not put the minimum number, suppose here in this case one, automatic scaling group, auto scaling mechanism will not know that we need to maintain the minimum number, and it will not try to spin up a new instance because you did not mention the minimum number, right? Desired capacity is the capacity wherein it will try to keep the number of instances at the desired number of level, but at a minimum this is a guaranteed, right? The minimum number of instances will already be there, right? Now I was telling about this, the DDoS attack scenario, and this is very interesting actually, because you might see this in your real life as well, right? So suppose we did not mention maximum size, or maximum size is maybe too big, so maybe 100,000 instances it can scale to, right? So what happens in case of DDoS? Your system will try to, your application will try to absorb that attack. So suppose your instances are capable of catering to 10,000 requests per second, which is fine. So four servers, you have two servers or four servers you have spin up, they are able to absorb 10,000 requests per second. A DDoS attack started, then it increased to 20,000 requests per second. So auto scaling triggered because servers, suppose you have created a policy that if CPU goes beyond 50%, spin up four more instances or 10 more instances. So for 20,000 requests per second, it will keep on increasing your capacity. So instead of four instances, now you have say 10 instances. Now 50,000, you have 100 instances. Now it is maybe 100,000, 1 million. What will happen? It will keep on increasing your capacity, so your EC2 instances in this case, to a massive number, right? And it will, your application will, your infrastructure will absorb that attack. So your customer experience is there. So legitimate requests, which are your customers, their requests will not be dropped because we have massive infrastructure. But the implication is you will pay for all those thousands of instances which has been spent, right? So this is a trade-off you have to work out, right? What should be the maximum size at which, which makes the business sense, because you want to give the best customer experience, but it should fit your business objective as well, right? So if you see, like, if beyond this, if there is a DDoS attack, I'm ready to take a hit. My application may down for a couple of minutes, but I will not go beyond that, right? Now there is one caveat to this. So I'm not sure if we have gone through AWS's DDoS mitigation service called Shield. So Shield is basically AWS's DDoS prevention and mitigation service. So if you are a subscriber to that Shield Advanced, so there are two: Shield Standard, Shield Advanced. So Shield Standard is free of cost for everyone. Shield Advanced is a paid service. I believe it is 15K per month, minimum 3-month contract. So if you are the customer for that service, you opted for that service, what will happen? It that AWS will absorb all the capacity which was spun during a DDoS. So suppose instead of 100 instances, there were 10,000 instances more, which were scaled during that DDoS attack. Then AWS will refund you that money. Actually, AWS will not charge you for that particular time wherein 10,000, but the downside, not the downside, but the trade-off is you are already paying 50K per month, right? So most of the enterprises are customers of this AWS Shield Advanced, because their application is critical. But just bear in mind that there is, we always say, there is no magic wand, that there is no recommended architecture whatever fits your purpose, right? So sorry, I took little long to explain, but I thought it's important. um Now, okay, so little bit about the launch template. So launch template, as I said, it has uh, building blocks of EC2, which without which you cannot spin up an EC2 instance. But you want to have a seamless performance as well, right? So you want that template to be used by all the EC2s which you are going to spin. So you need to have a centralized governance. So what it provides actually? So the launch template provides a centralized governance model wherein you create one launch template and all the EC2 instances will be spun up using that launch template. And it is easier to roll out the changes. Suppose your requirement changes. So in the original template, you have a certain family of instance, right? Now your demand changes. You want to have a different family of instance, right? Uh, so in that case, what you will do, you can have a second version of this template. So suppose the versioning also. So you can copy the existing template. You can make whatever changes. So earlier it was EBS volume of 100 GB per instance. Now you can have EBS volume of 500 GB. You can change a security group. You can change whatever changes you want to make. You can have it as a second version, and you can that for certain number of for new security new auto scaling groups, or you will use it as the default template for all the EC2s going forward, right? So this is what launch template provides, and obviously it increases the productivity because all the configurations are centralized. EC2s will take those configurations, and all the new EC2s will be spun up using that, right? um Now this is a sample of launch template. We'll create one, by the way, right? So don't worry too much about it, but this is how it looks like. So I just created a non-template. So you give it a name. Default version starts with 1 because this was the first one. You mentioned the instance type. In this case, I selected T2 micro. You can select whatever you want, right? Which OS you want to use. So I took Amazon Linux AMI. Then security group, somehow it does not show availability zone and all, but you can select everything, right? And then you can refer this launch template in your auto scaling, and it will all the EC2s will use this. Okay, so just wanted to show this. Let me quickly see if there is okay. Yeah. So don't worry too much about these so many boxes in here, but just want to give you an idea how scaling out and scaling in actually looks like. So when a scaling event triggers, so that this top green thing, when scale out events trigger, so instance goes from initiating to pending, and then from pending to in service. And when it goes to in service, the auto scaling service, it makes the server the EC2 instance active, and it can start receiving the traffic. And same happens in case of scaling in event, wherein your load is reduced. Then you want to terminate all those extra instances which you have spun up. So it goes from in service to terminating to terminated state, or maybe if there is a health check failure, then also it goes to terminating state. And you can manually also detach the instance, right? So you can just remove the instance from that group. Now there are you sometimes you don't want the automated behavior, that you don't want instance to simply just start and become active and in service, right? You want to run some sort of scripts, or you want to monitor what is being spun, or maybe you have some sort of validation mechanism, and this is where life cycle hooks come into picture. So what it is basically, so life cycle hooks is you can break this automated process. So instead of going from pending to in service, what you can do, you can invoke lifecycle hooks, and you can run some sort of scripts. If you want to run, you want to install some sort of software, you want to take some sort of logs, or maybe whatever you want to do, right? So you can just pause this process, and then the instance goes to in service. Same you can do for the scale in event, right? When an instance is terminating, from terminating to terminate, it does not directly go. Suppose you want to take some logs, like whatever was there, you want to take a snapshot of this, you want to run some sort of analytics, whatever you want to do with it, right? You can just add a life cycle hook in here, and you can perform your analytics. So sometimes it is important, because for the compliance reason, you want to make sure whatever instance spun up or you are terminating, its contents are saved for any compliance reason, right? So you may want to take a snapshot before terminating, right? Or you want to just download the logs, like who connected to these instances, and what did they do, what API calls they made, and all, right? So you can do that. Now there are a couple of scaling options. uh, Obviously you can do manual scaling. So what you can do, you can go and change the size, and you can increase the capacity minimum desired, and or reduce it, right? So manually you can do, but in today's world, we normally avoid doing anything manually, right? So second is predictable scaling, wherein based on the previous performances, as I said, you can perform your scaling events. So at certain times of the week or certain days of the week, my performance is this, so I'll make sure that my servers are available to cater to new requests, right? You can have a scheduled scaling. I can give you a nice example of the scheduled scaling. So one of a very famous this uh, food delivery app notice that every day at around 6 they see a surge in their orders. So what people are doing, when they are finishing their office, they are just ordering food on the way to their home. So by the time they reach, their food is getting delivered nice and hot, right? And they saw the pattern, right? So they scheduled the scaling. So instead of 100 servers, they need 10 times that servers, right? So they can have thousands of servers ready when the customers need them. So at around 5:30, they already have servers spun up, so they can seamlessly cater to new customer requirements. So you can schedule it, but you need to know the schedule, right? So obviously, so this is what that delivery app did, and it is actually working good. Now we have dynamic scaling also, right? So based on certain triggers, you can have scaling out or scaling in events, right? Based on how the traffic profile changes. Now there are three ways you can change this: simple, step, and target tracking. So in simple scaling, you can have simple CloudWatch trigger. Just maybe EC2 CPU goes beyond 60%, trigger auto scaling event, right? If it goes below 30%, then scale in event, right? So you can have a simple scaling, or you can have step scaling. So in step scaling, based on the level of breach of the alarm which you configure, suppose CPU alarm you configure, you can scale in steps. Like if the CPU is 40%, add 4 more instances. If CPU is 60%, add 10 more instances. If CPU 80%, add 100 more instances. So in steps you can do the scaling. And third is the target tracking. So it is, so you the I can give you an analogy of say thermostat at your home, right? You set the temperature to 22 degree. What it does, it keeps on switching on and off your heating system, like boiler or whatever heating system you have, to maintain that temperature, right? That 22-degree. You don't have to do anything. It will automatically switch on and switch off your heating system. So same thing, you can have a target. Not target, can be memory, it can be CPU, it can be anything else as well, right? Number of connections and all, right? It will make sure that level is maintained, and for that, whatever is needed, like scale in or scale out event needed, the system will take care of it, right? So depending upon your need, you can have any of these, except manual. The suggestion would be um okay. So now quickly, why do we really need it, right? So it is easy to auto scaling. So it increases the fault tolerance, because you want to make sure that you have your application available, and if some instances they're failed for some reason, there maybe if it is HTTP based application, HTTP daemon failed, or some services crashed, there's a memory leak, anything, then the system should automatically be able to replace that instance, and your customer experience should not be, you know you want a good customer experience, right? So it provides the fault tolerance, right? It provides the increased application availability if there is a problem in any of the availability zones, and you have some sort of capacity already planned, then your application, whatever capacity it is baseline for, it will always be available, right? And obviously it is lower cost. Now, why it is lower cost? Because you have increased capacity only when you need it. It's not always there, right? So when you don't need it, it will terminate those extra infrastructure, and it will save you money, right? So it is cost effective as well. Now let's have one example of an application, right? So it is a basic web application. You have a meeting room booking. Suppose this is a application for your office to book meeting room. Now this is the usage pattern you see here. So Sunday, Monday, it is little low, but midweek it is high, and towards the tail end of the week it is little low, right? So this is the usage pattern. Now to cater to this, there are couple of mechanisms which we can use, right? So first is the traditional way, like what we do. And by the way, this is not limited to cloud, right? This is very well valid for the on-premise as well, and this is how we do in on-premise, and that's why there is a push to move to cloud. Now in on-premise, what we do, we baseline the application, and we cater for the peak performance, right? So suppose you baseline that at the peak we need 100 servers, right? Then we will have those 100 servers always ready. Even when we need 10 servers, then also 90 servers will be sitting idle. We need 50, we'll have 50 servers sitting idle, right? So there is a big unused capacity. You are paying for it. And in cloud also, in AWS also, if you go for this option, then there is an unused capacity, right? You don't want that, because it is against the well architected principle, right? So what you can do, other option is to average it out. So you have an average that, okay, you need 100 servers, then maybe have around 60 or 70 servers provision. This has a little plus side, is it is less expensive, but it is bad customer experience, because for this time when customers need this application, their request might be dropped because there is not enough capacity available, right? So this average capacity option is also not very good. Now what we can do to avoid extra charges and avoid poor customer experience, we can do it with auto scaling. So whenever we need extra capacity, we have extra capacity. Whenever we don't need extra capacity, we terminate that instance, right? So this way, the capacity and the available infrastructure is almost the same, little bit high, but not that much, right? So it ticks both boxes. First is it is better customer experience. Second, less cost, right? So this is what ideally you want to achieve. Right now, okay, so after this, it starts with elastic load balancing. So I think let's have a quick demo of auto scaling group before starting with elastic load balancing, so that there's um, you can see how it actually works. Let me see. Um, what is the time? Okay, so it's like just 14 minutes. So I think we can have a demo for maybe next 20 minutes, and we can take a 5-minute break to grab a cup of coffee and bio break, and then we can continue, right? So 1 second. Let me share my. Just give me 1 second. Let me open up my browser. Okay, so here it is. I hope you can see it. Yes. Okay. So let's have a quick demo of auto scaling group, right? We'll just you know go. We'll just create a group, and we can alter the in number of instances than the desired one. So the system will take care of recovering the terminated instances, right? So this is AWS console, nothing fancy in here, right? So this is AWS console.
Ashutosh, probably you
Yeah.
can increase the font size of the screen. This
Let me see.
you just zoom it to around 125 or yeah, something like that should be fine.
Is it good?
Yeah, it looks good to me.
Uh, yeah, sorry. Actually, this monitor actually is big, so it actually scales everything up. So for me, it might seem too big, but let me know if it is still problematic. I'll increase more. Okay. Okay, so here this is the EC2 console, right? So in the auto scaling group, what you can have, you can create a auto scaling group in here. So for that, you need some sort of launch template as well, right? So first you need to create a launch template, but it takes so this console takes you there as well. So we can start here. So maybe test auto scaling group, right? We need to select a launch template because without which we cannot launch an instance, right? So we need to create a launch template as well. So give it any name, version one. This is, right. So you select the OS. So currently I have one EC2 instance which is already spun up. So I'm just taking that AMI, but feel free to choose any AMI you want. So it is just asking for the operating system you want to use, right? So we have selected that. Instance type, you can select whatever instance type. So T2 micro, because you need to have instance family. Then if you want to log into it, you can select a key pair. It's not needed actually, but because we are not going to log into the instances, but for the completeness, because in reality you may want to have access to that, right? So okay, and then security group, any security group you can choose. And then whatever volume, whatever hard disk you want to attach, you can attach. So it is default 8 GB EBS GP3, but you can change it if you want. And this these are just spot instances, and all these are advanced setting. If you want to have some sort of user data, so if you remember when you launch EC2 instance, you can prime it with some sort of maybe you can update the software, you can download something, you can install something, and start some application, right? So this is the user data. So you can create a launch template, right? Now you can come here. Now this template is available. This is a default template. You It will ask to select a VPC because you want your instances, they reside within a subnet and subnet resides within a VPC, right? So you select a VPC. You select the availability zones. I have only one subnet in one availability zone, so I have selected that. If you have more, it will show you more. And currently we don't have any load balancer, so we don't want to use any load balancer. No VPC lattice, which is one of the new services. Rest all is just default. Now this is where you create the group wherein you have desired capacity, maybe less 2, minimum capacity 1, maximum capacity whatever 3, right? You can have target tracking, you can track CPU, you can track whatever, memory and all. Next. Okay, so this is the group we created. So if you see, it is, since we have the desired capacity as 2, right? So it is triggering the launch event. So it is launching new EC2 instances, right? So it is launching 2 new instances because it wants to maintain that capacity, right? So if you see, it is updating the capacity in here. So if we come here, we should start seeing couple of instances, right? So these 2 instances, they are just spun up using this auto scaling group. So if you just come here, you see the launch time, they'll just show like 1 minute before. If you see here, this, so these are the instances, these 2 are the instances which are just spun up, right? Just for the argument's sake, this was the old instance, right? It was around 11 hours before. So these are the 2 new instances which are spun up using this auto scaling group, right? So here if you come, what you can do, you can have, so in real life scenario, what you want to do, you want the automation, but you want your system admin to know what is happening. So there was a problem, it is taken care of, but you need to have some sort of log, right? Some sort of notification. So what you can do, you can create a notification. So it, i'm I'm not sure if you know about SNS, but SNS is a simple notification service from AWS. I hope you know. So here you can create uh, a notification service that base auto scaling event triggered. Then you can have, so I created email address just for this and create, oh, okay, sorry, fully uppercase lowercase, so you cannot have, you can have dash, I think. Okay. Yeah, so what it will do, um let me open Yahoo. Sorry, who uses Yahoo Mail these days, but okay. Okay, so you know, I just created yesterday only this email, so that's why you don't see too many emails. So here, whenever you subscribe to any of the topics, you need to have a, you need to confirm it, because otherwise you can spam anyone's email, right? So you need to confirm. Once it is confirmed, all the scaling events, you will see an email with. So yesterday I just did some tests, and see, you will see if any an EC2 instance is terminated, then you will see a notification like what happened, what was the uh, instance ID, what actually happened, EC2 instance terminated, and if there is a new instance triggered, then EC2 instance launch. So let's give it a try now. Okay, so we have two instances which are in service. So two instances, if you see, they are healthy because the desired capacity is 2, right? Now let's go, and maybe something happened to this instance. It crashed. Let's crash it. Terminate. Right. So what it will do, it will perform the health check, whatever time it was configured. Actually, I did not see, maybe 100 or 200 seconds. After that, it will declare the instance as unhealthy, and it will try to maintain the desired capacity, right? To come to the auto scaling group activity. Let's wait for some time because it needs to go through the health check and it needs to fail the health check. It's still healthy. Sorry, I should have changed this from 200 seconds to maybe 50 seconds, but let's wait. And let's see if we get any notification also. So there is a health check wait period, so it needs to expire before it actually triggers. So it is actually updating the capacity, so we can just wait for some time and it will automatically. Maybe let's terminate one more instance to force it. Okay, so if you see, we got a notification. You can get an SMS also. I just choose email, but you can get SMS also. So an event triggered actually. So auto scaling service triggered an event. It's called EC2 instance terminate because we terminated the instance, and it goes through that health check cycle, whatever 200 300 second it was, and it declared that okay, instance is not there anymore. So what it will do, it will try to mitigate that, right? How it will try to mitigate? It will try to spin up new instances. So if you see one instance already initializing, right? So it will try to maintain that capacity, whatever you configure. So these two instances are terminated. These are old instances. New instances will be spun up. So here, if you go to a scaling group, it shows two instances. There should be two instances technically. Yeah, there is some, the dashboard takes little bit of time to update, but eventually we will have two instances. So the whole idea of this is to show you that how you can manipulate your not manipulate, not the right word, but how you can configure your auto scaling groups to maintain a desired capacity of instances. So whatever happens to that instance, maybe a daemon failed, or maybe it is somebody shut down those instances, or maybe an availability zone failed, or anything happened to that instance, your number of instances will always be available, whatever capacity you have configured, right? So see, this one more instance which is coming up now. So eventually it will have two instances, and your system admin will get a notification also. So there is a launch event, and it is launching a new EC2 instance, right? So this was little demo of, and this is the second instance. So second instance also terminated, and after some time you will see second instance launch. Okay, so second instance launch. So these are the chronological events. So one terminated, launch, another terminated, launch, right? So eventually you will have two new running instances. So this one and this one. These are the new instances which just just started. You know, 3 months ago. Okay, so that actually is it. You can change it, right? So okay, let me show you one more thing. I told you, right? So you where is the launch template? Yeah. So launch template. So suppose you want to change it, right? Modify the template. So the name will remain same, and it is whatever version 2, and you put new instance family, right? Okay, so before that, let me show you one more thing. So here, if you see, the new instance is of type T2 micro, right? So suppose requirement changed and you want a bigger instance, right? So you can go here, you can change it to a different, maybe whatever, C5 large, right? So what it will do, it will, going forward, if you use this launch template, it will launch the instance in that particular family. So this is where this mutable feature comes into a picture, that based on the requirement changes, you can modify and version control your launch template. So you don't have to just start from scratch. You can use the old launch template and you can modify it, and you can refer this launch template into the EC2 auto scaling group, right? So this is the default version. This is the latest version. You can change it, right? So this is okay. So if there are um, any question in this, and see that there are so many options. Honestly, I just maybe just touch the tip of the iceberg, right? The best way to learn AWS is just try it out, right? There are hundreds of uh, videos, small videos, tutorials, they are available. Just try out various things. Maybe just have one script. I'll after this I'll share some documents, like a CPU hogging script, right? You run that script. When the CPU goes beyond certain capacity, you create that threshold, and you can just trigger that event. You may hog memory, right? And you can check whether your memory policy triggers or not. You can create a CloudWatch alarm and associate that alarm with your auto scaling group. So it will trigger, first CloudWatch will trigger an alarm, that in turn will trigger a policy, and your instances will be scaled out. And when you stop that script, it will be scaled in, right? So you try these various things, and you can use auto scaling group with load balancer as well, right? Because we will, in the next session after 5-10 minutes, we'll see that you may have 2 instances, 10 instances, or 100 instances. In isolation they are not good, right? Because you want some sort of front end to front those instances, and this is where the load balancing service comes into picture, and this is where you can use auto scaling group as well. So you can front load balancer, uh, you can front your auto scaling group with a load balancer, so it will maintain the capacity. and load balancer will front all the requests, so you get a better customer experience. So there are various ways to how you may want to use it, right? So let's okay, so that's it from auto scaling group point of view. I just touch few things just to give you a flavor. Please feel free to try it out, and maybe we can take Prasad. Shall we take maybe 5 minute break and
Yes. Yeah, let's
and
do that. Thanks, actually, this is really good. Like especially what you showed on the console, that was really helpful. So yeah, as Astro said, best way to learn AWS is like get your hand dirty, like try different things. And yeah, Ashutosh, do share those CPU hogging scripts and other scripts.
yes,
We have our resources sections. We will upload those in our resources sections so that people can like use that.
yes,
Okay.
yes. Good.
So cool. Let's take that. I'll share my screen. Hold on. There should be a easy way to screen. Okay. So let's take a 5 minutes break, and then we will be back. The timer starts.
Sure. See you all.
See you all.